The U.S. Space Force now frames its central task as achieving space superiority, and its 2025 doctrine identifies orbital warfare, electromagnetic warfare, and cyberspace warfare as the three main mission areas of space control. At the same time, the service's warfighting framework, its commercial strategy, and current SDA and SSC planning all point toward a future built around proliferated constellations, missile tracking sensors, optical links, responsive launch, autonomous operations, and tighter military-commercial integration. When most people hear the phrase space warfare, they picture laser beams, exploding satellites, and one very intense general pointing at a glowing map. The real future is both more technical and more unsettling than that. It is less about one giant superweapon and more about a web of smaller, faster, smarter systems that can see more, move faster, hide better, recover quicker, and make the enemy's life miserable without always producing that cinematic explosion people seem to crave. That is where the story starts. The future of military technology for space warfare will revolve around six things: sensing, networking, autonomy, mobility, hardening, and the ability to regenerate losses quickly. If that sounds a little less glamorous than space battleship, I regret to inform you that reality has once again refused to hire Hollywood as a consultant. The first major technology is proliferated satellite constellations. For a long time, military space power leaned heavily on a small number of exquisite satellites. These were enormously capable machines, and also enormously tempting targets. If an enemy could disrupt or destroy a few key systems, he could do real damage. The newer model is very different. Instead of building a handful of orbital crown jewels, the United States is moving toward larger constellations made up of many smaller satellites, spread across low Earth orbit, connected as a mesh, and built to keep functioning even if some nodes are lost. That is the basic idea behind the Space Development Agency's Proliferated Warfighter Space Architecture, which is being fielded in tranches and is designed to support missile warning, missile tracking, data transport, and resilient tactical communications. This matters because future space warfare will reward resilience more than elegance. A brittle constellation can be intimidated. A distributed one is harder to blind. If an enemy has to deal with dozens or hundreds of spacecraft instead of a few prized assets, his job becomes uglier, slower, and more expensive. In military affairs, that is often what passes for good manners. The second major technology is space-based missile tracking. This is one of the clearest areas where future space warfare and missile defense merge into the same story. The Space Development Agency's tracking layer and the Missile Defense Agency's hypersonic and ballistic tracking space sensor effort are aimed at persistent global sensing of ballistic and advanced missile threats, including hypersonic systems that maneuver in ways older architectures struggle to follow. In 2024, MDA and SDA launched HBTSS and tracking layer satellites together, and subsequent reporting around the program has emphasized the need for high-fidelity tracking and handoff for missile defense. That tells you where the future is headed. Space will not merely support war, it will increasingly determine who sees first, who tracks best, and who can hand targeting data to the right shooter in time. That may sound dry until you translate it into plain English. In the future, a satellite will not simply take a picture and send it home. It may detect a launch, maintain custody of a maneuvering threat, pass that track through a space mesh network, and support an engagement decision across multiple domains. That is not a side function. That is warfighting. The third major technology is optical communications. This is a quiet revolution, though quiet in the way a lockpick is quiet. It matters a great deal when someone is trying to get in. The future space battle space will rely more heavily on laser communications between satellites and ground terminals, and eventually between satellites and aircraft. SDA has been building toward an optical mesh for the PWSA, and in early 2026, it issued an RFI specifically aimed at future space-to-air optical communication terminals, with the goal of enabling resilient air-to-space optical links and a possible initial operational capability as soon as 2027. GAO reporting has also highlighted laser communications as a core part of the architecture. Why does this matter? Because future space warfare is a contest over data as much as metal. The force that can move targeting information, warning data, and command traffic securely and quickly will have a major advantage. Optical links promise high bandwidth, low probability of intercept, and reduced dependence on vulnerable terrestrial relays. In other words, they are part of the effort to make the military's orbital nervous system harder to cut. The fourth major technology is autonomous operations. Future military systems in space will have to make more decisions without waiting for a human operator on the ground to fuss with a keyboard and a mug of stale coffee. The distances are too great, the timing windows too tight, and the number of objects too large. Autonomy will matter for collision avoidance, satellite maneuver, target characterization, onboard data processing, threat response, and constellation management. The broader Space Force push toward warfighting readiness and long-term force design reflects this reality, even when the documents speak in the polished language bureaucracies use when they are trying not to alarm anyone before lunch. This does not fully independent killer satellites roaming orbit like something dreamt up by a man who has not seen the sun in 6 weeks. It means software-defined spacecraft, onboard decision aids, automated mission management, and faster, machine-supported responses to threats. The future will belong to constellations that can coordinate themselves and adapt under pressure. A satellite that has to wait politely for every instruction may be a lovely bureaucrat. It will also be dead. The fifth major technology is on-orbit servicing, inspection, and rendezvous. This is one of the most important and least appreciated parts of the future. DARPA's robotic servicing of geosynchronous satellites program and the broader CONFIRS effort are both centered on the technologies needed for inspection, servicing, and close proximity operations in orbit. On paper, this sounds benign, even helpful. In practice, any technology that allows a spacecraft to approach, inspect, manipulate, repair, or refuel another spacecraft has obvious military significance. The same robotic arm that can service a friendly satellite can interfere with an unfriendly one. The same rendezvous technology that supports repair can support coercion. Space is a domain where the line between mechanic and mugger can get uncomfortably thin. This is why future space warfare will involve much more close proximity maneuvering and much more anxiety about intent. A servicing craft may be a lifeline, an inspector, a spy, or a weapon waiting for the right phone call. The technology is dual use almost by definition. That makes it strategically valuable and politically awkward, which in Washington is usually the sign that a capability is very real. The sixth major technology is responsive launch and reconstitution. If a war in space begins, one of the first questions will be whether a damaged architecture can be replenished fast enough to matter. This is where tactically responsive space comes in. Space Systems Command has been pushing these capabilities, and recent reporting shows the Space Force continuing exercises and demonstrations aimed at launching replacement payloads quickly in response to on-orbit threats. The point is simple. A future force that can replace losses rapidly is harder to deter and harder to cripple. This is one of the least glamorous technologies in the discussion, and one of the most important. History is full of militaries that loved exquisite platforms and forgot about replacement. They usually discover the error after the enemy has helped them count. In space warfare, fast launch, modular buses, ready payloads, and smoother launch logistics may matter more than grand speeches about dominance. The seventh major technology is electromagnetic warfare against space links. The 2025 Space Force Doctrine and its electromagnetic spectrum doctrine are very clear that controlling the space domain involves more than physically attacking satellites. It also includes combat operations on the link segment through electromagnetic fires, which means jamming, spoofing, interference, and the broader struggle over signals. The DIA's public threat work likewise describes a counterspace continuum that includes reversible effects such as denial, deception, and EW, alongside directed energy, cyber, and orbital threats. This is crucial because future space warfare may often begin with reversible attacks before it moves to destructive ones. Knocking a satellite permanently out of orbit creates debris and political consequences. Jamming its communications, spoofing its navigation, or dazzling its sensors may achieve much of the same effect with less noise and more deniability. Expect future military technology to pour money into protected waveforms, adaptive antennas, smarter signal processing, anti-jam navigation, and systems that can keep operating in a degraded environment. The glamorous version of war gets the posters. The ugly little signal war often gets the result. The eighth major technology is cyberspace warfare against the ground and network layer. People talk about space warfare as if the fight happens only above the atmosphere. That is charming. It is also wrong. The ground segment is often the soft underbelly of the whole enterprise. Space Force doctrine now explicitly treats cyberspace warfare as one of the three core mission areas contributing to space control. And later doctrine on the information environment describes both offensive and defensive cyberspace warfare in support of controlling the space domain. The 2025 China Military Power Report also states that Chinese state-sponsored actors have compromised and pre-positioned themselves within U.S. space and defense networks, likely for intelligence collection and preparation for disruption during conflict. So the future of military technology for space warfare will include hardened mission networks, zero-trust approaches, better encryption, software assurance, active cyber defense, and architectures designed to keep a cyber breach from turning one satellite problem into a constellation-wide disaster. A force can have brilliant vehicles in orbit and still lose because some miserable little admin console on Earth was defended like a folding chair in a hurricane. The ninth major technology is advanced space domain awareness. You cannot control what you cannot see. And in space, the seeing problem is harder than many people realize. The Space Force's doctrine and framework emphasize the need for comprehensive space domain awareness, while older but still relevant work on surveillance systems and SDA programs points toward a future of better tracking, better characterization, and better prediction of hostile behavior in orbit. Future systems will rely on improved ground-based sensors, space-based sensors, AI-assisted data fusion, and more persistent monitoring of objects that maneuver in suspicious ways. This matters because future conflict in orbit will often begin with behavior that looks ambiguous. A satellite drifts closer than expected. A servicing vehicle lingers too long. A platform changes orbit in a way that makes operators nervous. Advanced SDA helps decision-makers separate routine space traffic from threat behavior before panic does the job badly. That is a precious service in any military domain. In space, it may be the difference between a warning and an obituary. The 10th major technology is hybrid military commercial architectures. This is one of the biggest shifts underway. The 2024 USSF commercial space strategy states plainly that the Space Force will be more resilient and capable if it combines organic capabilities with those from other providers and integrates organic, allied, and commercial solutions into hybrid architectures. The DoD commercial space integration strategy makes a similar argument about access, integration before crisis, and mission assurance across the spectrum of conflict. That means the future battle space in space will not belong solely to government satellites. It will be a tangled system of military spacecraft, commercial communications, commercial remote sensing, allied contributions, and data services stitched together before a crisis begins. This increases resilience and speed, though it also creates awkward questions. What happens when commercial assets become military enablers in wartime? What happens when private networks become too useful to leave alone? The future of space warfare will involve contracts and lawyers almost as much as rockets, which is perhaps the bleakest sentence I have spoken all day. The 11th major technology is mobility and maneuver. Future spacecraft will need more fuel flexibility, better propulsion choices, smarter station keeping, and greater freedom to reposition as threats evolve. A spacecraft that cannot maneuver becomes a hostage to orbital mechanics. A spacecraft that can maneuver intelligently becomes harder to target, better able to inspect, and more useful in a contested environment. This is especially true in geosynchronous orbit and cislunar space, where future competition is likely to reward mobility, persistence, and the ability to operate at greater distances with less support. DARPA budget material has also pointed toward interest in cislunar operations, precision navigation and timing, and proliferated architectures as areas of ongoing study and development. The 12th major technology is precision timing and navigation alternatives. Everyone loves GPS until it gets jammed, spoofed, or attacked. Then suddenly the room fills with people rediscovering humility. Future military technology for space warfare will place greater emphasis on resilient PNT, whether through improved satellites, crosslinks, alternative sources of timing, inertial backups, terrestrial augmentation, or systems that can fight through degraded conditions. This does not get as much public attention as anti-satellite weapons, though it should. A force that loses trusted timing and navigation can become clumsy very quickly, and clumsy forces have a bad habit of becoming memorials. So what does all of this add up to? It adds up to a future in which space warfare is less about one decisive strike and more about system versus system competition. The winners will be the states that can sense earlier, connect faster, absorb losses, restore function, and operate through attack. That is why the newest doctrine and planning language from the Space Force revolves around space superiority, contested operations, resilience, and long-range force design, rather than fantasy gadgets. There will still be destructive weapons, of course. Kinetic anti-satellite systems are not going away. Directed energy threats are still part of the picture. So are cyber attacks and close proximity systems that can hold targets at risk without blowing them apart. But the deeper trend is toward architectures that make destruction less rewarding. If you can regenerate, reroute, reconstitute, and keep fighting, then the enemy's attack buys him less. Deterrence gets stronger when offense gets less satisfying. That, in the end, is the real future military technology for space warfare. Not an imperial battle station, not a silver bullet. A layered, networked, semi-autonomous, heavily sensed, rapidly replaceable military ecosystem in orbit and on the ground. One that mixes government and commercial systems. One that treats communications, cyber defense, tracking, logistics, and reconstitution as warfighting functions rather than backstage chores. One that assumes the enemy gets a vote, and probably a jammer. The old view treated space as a pristine support zone floating above the real fight. The newer view is harsher and more accurate. Space is becoming a fighting domain shaped by software, sensors, networks, maneuver, and industrial speed. The states that understand that first will not merely have better satellites, they will have better odds. And in war, that is usually the difference between theory and wreckage.